Hi everyone, and welcome. In this video, I'll show you how to install and set up Indoor Nav, an open-source Android starter kit for indoor AR applications. It provides a foundation for building projects like indoor navigation or AR scavenger hunts, with AR tracking, waypoints, route graphs, pathfinding, and localization already included. Keep in mind that this is an experimental starter kit, not a finished product. The current version uses Google Cloud anchors for localization, which is suitable for prototyping but has limitations such as anchor expiration, occasional localization failures, and the need to rescan environments. A future version is planned to use the Indoor Spatial Platform, ISP, for more reliable localization. By the end of this video, you'll have the project installed and ready to explore. Let's get started. Now let's open the README and follow the Quick Start guide. The first step is to open docs/setup.md. Before installing the project, make sure your phone supports Google ARCore. Search for ARCore supported devices, open Google's official list, and check whether your phone model is included. You can find your device model under Settings, then About Phone. If your device isn't on the list, the application won't work. Next, make sure you're using a data USB cable, not a charge-only cable. Now we'll enable developer options and USB debugging. Open Settings, go to About Phone, tap Build Number 7 times. Then go back to Developer Options and enable USB debugging. You'll also need the Android SDK and ADB on your computer. The easiest way to get both is by installing Android Studio once. During installation, make sure the Android SDK is selected. Open Android Studio once to complete the SDK download, and then you can close it. We'll be using Cursor as our code editor, so Android Studio is only needed to install the SDK. You'll also need JDK 17 or later, since Gradle requires it to build the project. Once everything is installed, connect your phone using USB. When prompted, allow USB debugging, and if this is your own device, you can also check Always Allow. Now connect your Android phone to your computer using a USB cable. If this is the first time connecting, you'll see a prompt asking whether you want to allow USB debugging. Tap Allow, and if it's your personal device, you can also check Always Allow from this computer, so you won't be prompted again. Next, let's verify that ADB can detect the device. Open PowerShell and run the command shown in the documentation. If everything is set up correctly, you should see your device listed with the status device. Once your device appears with the device status, we're ready to move on. The next step is to set up a Google Cloud ARCore API key. This is required if you want to save markers to the cloud. Without it, MarkSpot will only work locally and you may see a not authorized error. Open cloud-anchors.md and let's go through the setup. First, go to Google Cloud. Create a new Google Cloud project. You can give it any name you like. Once it's created, make sure it's selected in the project picker. Now open the credentials page using the link in the documentation. Click Create Credentials, then choose API Key. Don't select OAuth Client ID. Google will generate a new API key for you. Copy it because we'll need it in the next step. For better security, open the API key you just created. Under API Restrictions, select Restrict Key, then choose ARCore API. You can leave application restrictions set to None for now while you're testing the project. Finally, click Save. Now go back to the project in Code Editor and open the local.properties file. If the file already contains a sdk.dir line, leave it as it is. On a new line, add ARCORE_API_KEY equals your_API_key_here. Replace your _API_key_here with the API key you copied from Google Cloud. Then save the file. One important thing to remember is that local .properties should never be committed to Git because it contains your personal API key. Finally, connect your phone. Make sure USB debugging is enabled and Wi-Fi is turned on. Then open a terminal in the project folder and run the Gradle command shown in the documentation. This will build the project and install it on your device.
Now let's open the app to make sure everything is working correctly. If the installation was successful, the app should launch without any issues. If you run into any errors, don't worry. Double check that you've completed all the previous steps correctly. Once the app opens successfully, we can move on to creating our first indoor map. Now we're going to start marking positions. To get the best results, slowly scan around the room first so ARCore can understand the environment. Once tracking is stable, place your first marker. I'll name mine Room 1. After placing the marker, don't move on immediately. Walk around it a few times while keeping it in view. This gives the system more visual information and helps it localize the marker more reliably later. One important thing to check is the status message. Wait until you see saved in cloud before moving on. If you see an error or it never reaches saved in cloud, your Cloud Anchor setup probably isn't configured correctly. In that case, go back and make sure your API key and cloud setup are correct before continuing. Also, sorry if you notice some flickering in my recording. My phone's camera lens has an issue, so please ignore that. I'll fast forward this part since it takes a little while. Next, make sure to mark the room entrance as well. In my case, I'll call it Room 1 entrance. Entrances are important because they'll be used when connecting different rooms together. The better your scans and marker placement, the better your indoor map will be. I'll repeat the same process for the rest of the apartment. Next, I'll mark the dining room, then Room 2 entrance, and finally Room 2, giving us a total of 5 markers. Remember, after placing each marker, spend some time walking around it and recording it from different angles. It only takes a little extra time, but it makes a big difference in the quality and reliability of the map. Now that we've finished placing all the markers, the next step is to connect them together. Open the Connections menu. Here we'll create the paths that the navigation system will use. First, connect Room 1 to Room 1 entrance. Next, connect Room 1 entrance to Dining Room. Then connect Dining Room to Room 2 entrance. And finally, connect Room 2 entrance to Room 2. Think of these connections as building a route graph. The app uses these links to calculate the shortest path between locations, so make sure you only connect markers that are directly reachable from one another. Once all the connections are created, your navigation graph is ready for testing. Now, let's close the app and open it again. You might notice that the markers don't appear immediately. In many cases, simply scanning around one room is enough for the app to localize and load all of the markers. If not, just keep walking and scanning the nearby areas until they appear. How quickly this happens depends on the environment and how well the markers were captured during mapping. This is one of the limitations of the current prototype. There are ways to improve the localization experience, but I'll leave that for you to explore. After all, this is a starter kit that's meant to be extended and improved, not a finished production application. Now, let's test the navigation. Tap the Navigate button. We'll start from Room 2, so select Room 2 as the starting location and Room 1 as the destination. Once the route is generated, simply follow the 3D dots displayed in AR. These dots represent the navigation path from your current location to your destination. As you walk, you'll also see the remaining distance update in real time, along with text directions. For example, it may tell you to turn left toward Room 1 depending on your route. When you reach your destination, the app will display Arrived Room 1. At that point, you can tap Stop to end the navigation. Since this is an experimental starter kit, there are still plenty of areas for improvement. For example, instead of only showing 3D dots, you could add directional arrows, richer visual guidance, voice instructions, smoother path rendering, and many other navigation features. The current implementation is meant to provide the foundation that you can build upon. That brings us to the end of this tutorial. At this point, you should have the project installed, created your own map, connected the markers, and tested AR navigation from one location to another. Remember, Indoor Nav is an experimental open source starter kit, not a finished product. It's designed to give you a solid foundation that you can build on your own custom AR experiences. Like any prototype, it has its limitations. The current localization system isn't perfect, and there are many opportunities to improve the navigation experience, user interface, and overall reliability. That's exactly why this project is open source. If you need production quality localization today, you can integrate an existing commercial or VPS based solution, especially if you're targeting platforms that support those technologies. This project doesn't lock you into one localization system, so you're free to replace or extend it based on your own requirements. For this project, though, we'll be taking a different approach. In future updates, we'll be building a completely new indoor spatial platform, ISP, focused on providing more reliable indoor localization while keeping the navigation system modular and easy to extend. You'll find the GitHub repository, documentation, and all the links mentioned in this tutorial in the description below. If you found this project helpful, consider giving the repository a star. It really helps the project grow. And if you enjoyed the video, don't forget to like and share it with anyone interested in AR, indoor navigation, or Android development.